Let's practice graphing and finding points on a hyperbola. If I want to look at the equation x minus 2 squared over 25 minus y minus 1 squared over 4, first we know it's a parabola because of the minus sign here and both terms are squared. And we know it's going to be a horizontal parabola because that x term is positive and the y term is negative. Our center comes from these values. So the center of hyperbola is going to be 2, 1. Our a value is the square root of 25, which is 5. And our b value is the square root of 4, which is 2. Remember, we're going to need those two a values and two b values. So sometimes it's helpful to just go ahead and include those. I like to draw a sketch just to get a picture of what my hyperbola is going to look like. I know my center is going to be at 2, 1. And from what we just talked about with the oblique asymptotes, we know that they're going to create a rectangle. So to create that rectangle, I'm going to go up 2 and down 2, and I'm going to go over 5 and over 5. This creates a rectangle of which the diagonals are going to be my oblique asymptotes. From this information, we can also calculate our c value. We know that c squared is equal to a squared plus b squared. So c squared is going to be 25 plus 4, or 29, which tells us that c is going to be plus or minus the square root of 29. That c value can then help us find our foci. Notice these foci are going to travel along this line. So their y value is going to stay the same. And I'm going to label them as foci 1 and foci 2. But that y value is going to stay at 1. They're moving horizontally. And then our x value is just going to be the center plus the square root of 29 and the center minus the square root of 29. And likewise, we can find our vertices by using the values for a. So our vertices are also going to travel along that same line, which tells us that our y values are going to remain the same. And then our x values will change by a value of 5. So we add 5 to get 7, 1, and we subtract 5 to get negative 3, 1. And then if we estimate those asymptotes, we can see, again, these approach those lines. And this is roughly what our hyperbola will look like. Just like before, sometimes these hyperbolas do not come in standard form, and we need to be able to complete the square. If we have something like negative 16 squared plus 9y squared plus 96x plus 18y equals 279. We rearrange things to complete the square. I'm going to factor out the negative 16, which leaves me with x squared minus 6x plus 9 times y squared plus 2y equals 279. When I complete the square, I divide this by 2 and then square it, which gives me a plus 9. Multiplying by the 16, or the negative 16, gives me a negative 144. Likewise here, I divide by 2 and square it, which gives me plus 1, which on the other side gives me a plus 9. Factoring, I end up with negative 16 times x minus 3 squared plus 9 times y plus 1 squared equals, when I combine these terms, I end up with 144. And I changed my number there, sorry about that, 279. Continuing on, I want to switch my order so that that negative sign comes secondly, and I'm also going to divide by the 144. So when I switch my order here, I end up with y plus 1 squared over 16 minus x minus 3 squared over 9 equals to 1. From this form now, we can glean our information that the center is going to be 3, negative 1. Our a value is going to be 4, which results in a 2a value of 8. Our b value is going to be 3, which gives us a 2b value of 6. And our c value is the square root of a squared plus b squared, which comes out to be 5. This tells us then from our center being 3 that our vertices, this is going to be a vertical parabola, which means our x values won't change, but we will go up by 4, which leads us to 3, 3, and go down by 4, which leaves us to 3, negative 5. And then our foci likewise travel along that same line. We're going to have 3 plus, comma 4 and 3, comma negative 6. The asymptote lines, we can follow that same pattern from the equations we wrote before, and our asymptotes are going to be y plus 1 is equal to negative a over b, and that can be plus or minus, either one, 4 over 3 here, times x minus 3 are the equations for both of our asymptotes.